Hello, everyone. In this first lesson of our new unit, we're going to talk about identifying and testing solutions to equations. And right away, we're asked, is 7 a solution to this scary looking equation, x squared plus 5x equals 14, which obviously we don't know how to solve just yet. Maybe you do, maybe you don't. But we're going to pretend that obviously we don't. So how can we answer this? What we're going to do is take the value of 7 and substitute it in. So I'm going to plug in a 7 for x. Just like when we talk about substitution or plugging in when we did linear models and things like that, and we're going to look to see what happens. As you start moving through this, it becomes glaringly obvious that 49 plus 35 is going to be 84. We eventually lead to a false conclusion. I think we can all agree that 84 does not equal 14. So what can we sum up here? We could say, therefore, although we don't know just what the answer is, right? This only answered the question of whether or not 7 was. This didn't answer the question. We know 7 is not a solution. Just like with points being on lines, right? We said, hey, it's only on the line if it satisfies. 7 did not satisfy the equation here. An algebraic equation is a direct statement of equality. They often contain symbols or letters, which obviously we know as variables, whose values must be determined in order to complete the truth value of the sentence. Key point, and this is what you could jot down from the slide. An equation is true if and only if both sides of the equation are equal. A domain, vocab word, is a set of numbers that we can input into an equation. So when we refer to the domain of an equation, we're talking about, like traditionally we would say x, but any variable that's featured in the equation. The value or values plural that make an equation true are known as the solution set. So just some background vocabulary. Now, I'm not going to be able to feature this in the video. Perhaps I'll upload a separate one, but your calculator can help with a lot of the testing that we're going to discuss throughout this lesson and in this video using what's known as the store feature. And this is something that's not very commonly used by people. It's probably a button that you noticed right away when you bought yours just because you were curious about what it does. It's towards the bottom left, right above the on button. I'll kind of just give you a very brief demo right now. It says STO with an arrow. So that is the store button. So basically what this does, you can type in any number you like. So let's say you're testing whether or not 6 is the answer to something. So you'd hit 6, you'd hit the store button. So I'm just going to, in a way, show you what my calculator screen says right now. When you hit the store button, it gives you like that little arrow. And now you're going to choose whatever letter on your calculator that you want 6 to be stored as. Traditionally, most people use X. You could hit the X button. If you're curious where you can get other letters, that's where the alpha key comes into play. So you would hit alpha, and then if you notice, it might be in a different color in your calculator, but on mine it's like a light green color. We see A, B, C, D, E, F if you look above all the buttons. So you could use any letter you like. Most people probably just use X, which is right below mode. And now when you hit enter, every time you hit X, it's going to display a 6. So it's basically treating X like 6. You just stored the value of 6 for X. And now I can type an expression in using X rather than having to keep typing 6. This is particularly helpful if you want to evaluate like fractions or irrational answers that may be a little annoying or frustrating to type into the calculator. But we'll talk more about that. That's just some of the basics on how to store values on the TI-84. All right, so on this slide, we're going to be identifying the given x value in the left column, where it says -2, 3, 1/2, 5, and 2, is a solution for the given equation in the middle column. And we're simply going to say t if it is for true, or f if it's not for false. So starting with the first one, once again, we're kind of going through this lesson with the assumption that we don't know how to solve the equation that we're given. So I'm simply going to plug in a -2 for x. And now I'm just evaluating the truth value of the equation. So I'm going to get 5 minus 4 there. When I do 2 times -2 is 1. 2 times -2 is -4 plus 6 is 2. So I eventually get a line of 1 equals 2, which obviously tells me that -2 is not a solution. I'm going to indicate false there. For our second equation, I'm going to substitute in a 3. And obviously, we're eventually going to learn how to solve these. This is just identifying whether or not these numbers are solutions. So this is going to be -18 minus 20 is -38. On the right, in the parentheses, we're going to get 1 minus 9 is -8 times 4 is -32. We have the -6 up front, so -6 minus another 32 is going to be -38. So my eventual kind of closing line here is -38 is equal to -38, which obviously is a true statement. 3 is a solution to this equation. For the 1/2, this is where using the calculator might be helpful. We're going to substitute in a 1/2 for x. Now if we evaluate or simplify, we're going to get 8 times 1/2 is 4, plus 4 times 1/2 there is 2, minus 3 is -1, times the 4 out front is going to be -4. So on the right side, we're going to get 4 plus -4, or simply 0. Now on the right side, we have 6 times 1/2 is 3, plus 4 is 7, times 4 is 28, 28 minus 4 is 24. So we get 0 equals 24, which is clearly false. Now, how can you use your calculator for something like the third example here? You can store the value of 1/2 for x. So type in 0.5, store it as x. And now you can type that entire expression out. So you would literally just type 8x plus 4, parentheses. So I'm literally just typing in the equation into my calculator. Now you reach a point where you're curious where the equal sign is. So if you hit math, second math for test, it's the first option. You just hit enter and then continue typing the right side. So again, equals was found under second math. And if you hit enter, you're going to get a 0. All your calculator says is 0. Your calculator is going to basically output in binary. It's going to say 1 or 0. So when you type in an equation, you have to first store the value for the variable, right? So you have to say, hey, plug in a 1/2 here for x, or treat x like 1/2. Our calculator said 0. 0 is going to indicate that statement that you typed in is false, whereas 1 would indicate a truth value, that it is true. For the fourth example, plugging in a 5, we're going to get 5 squared minus 7 times 5. 25 minus 35 is going to be -10, so -10 does equal -10. This is true. Another quadratic. And the last one is cut off, so let's slide up. Plugging in a 2, we're going to get 2 squared minus 7 times 2. So we get 4 minus 14 is -10. -10 equals -10. Now, what do you notice about the last two examples? That's actually the exact same equation, and we just showed that this has two different solutions. So we'll introduce this a little bit more in the assignment that you're going to be working on. This is known as a quadratic. It's going to be a big focus throughout algebra, and the idea that, hey, equations can't just have, or can have more than just one solution like we're accustomed to. So this is a quick little lesson on just testing and identifying solutions. We'll talk more about the calculator fluency with storing values and typing in and the truth value, but if you're able to follow those directions verbally, that's great for now. Thank you guys for watching, and let me know if you have any questions on this lesson.